Breaking news from the cosmos, NASA is on high alert. Not one, not two, but 8 comets are currently diving through our solar system, and astronomers are scrambling to track them all. The headlines are calling it a comet parade, but this isn't just a pretty light show in the sky. We're witnessing something extraordinary. Leading this cosmic convoy is 3I Atlas, an interstellar visitor from beyond our solar system, carrying secrets from the deep void between stars. But it's not alone. 7 other comets are joining this celestial dance, each with its own story, its own dangers, and its own potential to revolutionize our understanding of the universe. Today, we're going inside NASA's comet tracking operations to understand why scientists are calling 2025 the year of the comets, and why some of these icy visitors have astronomers both excited and concerned. Before we dive into our cosmic visitors, let's understand what we're dealing with. Comets aren't just dirty snowballs, as they're sometimes called. They're time capsules from the birth of our solar system, 4.5 billion years ago. Picture the early solar system as a cosmic construction site. While the inner planets were forming from rock and metal in the intense heat near our young sun, the outer regions were cold enough for water and other substances to freeze solid. These icy chunks, mixed with dust and rocky debris, became comets, pristine archives of conditions in the primordial solar system. Most comets spend their lives in the frigid outer reaches, either in the Kuiper Belt beyond Neptune, or in the Oort cloud, a spherical shell of icy objects that extends nearly halfway to the nearest star. But occasionally, gravitational nudges send them careening toward the inner solar system. As a comet approaches the sun, something magical happens. The ice begins to sublime, turning directly from solid to gas, creating the glowing coma and spectacular tail that can stretch millions of miles. It's like watching a cosmic ghost materialize from the darkness. But here's what makes our current situation so remarkable. Most comet years see maybe 2 or 3 notable visitors. Right now, we have 8 active comets in various stages of their journeys, including one that didn't even originate in our solar system. Let's start with our most exotic visitor, 3I Atlas. That 3I designation is crucial. It means this is only the 3rd confirmed interstellar object ever detected passing through our solar system. Discovered on July 1, 2025, by the Atlas Survey Telescope in Chile. 3I Atlas is following what astronomers call a hyperbolic trajectory. In simple terms, it's moving too fast to be captured by our sun's gravity. This comet came from the void between stars, and after its brief visit, it will return to that cosmic wilderness, never to be seen again. Think of it this way. If most comets are like boomerangs that always come back, 3I Atlas is like an arrow shot from an unknown archer in the darkness. It passes through once and disappears forever. What makes 3I Atlas scientifically invaluable is its composition. Spectroscopic analysis reveals it's rich in carbon dioxide and water ice, and remarkably, it started showing activity, developing its coma and tail, while still incredibly far from the sun. This suggests its ice is more volatile than typical solar system comets, possibly because it formed in the different chemical environment around another star. Right now, 3I Atlas is racing toward its closest approach to the sun, called perihelion, which will occur in late October 2025. While it poses absolutely no threat to Earth, passing safely at a distance of over 100 million miles, it represents a once-in-a-lifetime opportunity to study pristine material from another stellar. NASA's Deep Space Network is tracking its every move, and observatories worldwide are collecting data that could tell us about the chemistry and physics of planetary formation around other stars. We're literally analyzing alien solar system material without leaving home. But 3I Atlas isn't performing solo. 7 other comets from our own solar system are putting on their own spectacular shows, each with a unique personality. C2025 R2 Swan is the potential showstopper of the group. Discovered just last month by the Solar Wind Anisotropes Space Observatory, this comet is on an extremely close trajectory. It will pass within 0.5 astronomical units of the Sun. That's about half the distance from Earth to the Sun. And more importantly for us stargazers, it will come within just 0.26 astronomical units of Earth. To put that in perspective, that's closer than Mars gets during its closest approach to Earth. Early predictions suggest C2025 R2 could become bright enough to see with binoculars, possibly sporting a tail several degrees long in our sky. Imagine looking up and seeing a cosmic sword slicing across the constellation. That's what we might be in for. C2025 A6 Lemon was the first comet discovery of 2025, spotted by the Catalina Sky Survey back in January. What's exciting about Lemon is its potential brightness. Current models suggest it could reach magnitude 3 to 5 at its November 2025 perihelion, making it potentially visible to the naked eye from dark sky locations. For comparison, magnitude 3 is about as bright as the stars in the Big Dipper's handle. If you've ever seen those stars clearly, you could see C2025 A6 Lemon without any equipment whatsoever. Then we have C2025 F2 Swan, and this one's a wildcard. With a perihelion distance of just 0.33 astronomical units, it's diving perilously close to the Sun. Comets that approach this close face intense heat and gravitational stress. Some survive and put on magnificent displays, while others completely disintegrate in a spectacular but brief fireworks show. We're essentially watching a cosmic game of chicken, and we won't know the outcome until F2 makes its approach. C2025 D1 Growler breaks all the normal rules. Most comets only become active when they get relatively close to the Sun, but Growler is showing activity despite having a perihelion way out at 14 astronomical units. That's nearly as far as Saturn. This tells us something fascinating about its composition. It must be made of extremely volatile ices that can sublime even in the frigid outer solar system. C2025 K1 Atlas, discovered in May by the same survey that found our Interstellar Visitor, represents the fragile side of comet nature. Early observations suggest this comet might be structurally weak, essentially a loose rubble pile held together by ice and gravity. As it approaches its 0.33 astronomical units perihelion, we might witness it break apart in real time, giving us a rare look inside a comet's structure. C2024 E1 Virchtos provides an interesting contrast, discovered last year and much fainter than its flashy companions. Virchtos reminds us that for every spectacular comet that makes headlines, dozens of smaller, dimmer visitors pass through unnoticed by the general public. These ordinary comets are often just as scientifically valuable, filling in our understanding of the comet population. Finally, C2025 R3 Pan-STARRS is playing the long game. With a perihelion scheduled for 2026, it's already under intensive study, showing how astronomers work months or even years ahead to understand these visitors. Pan-STARRS represents the patient, methodical side of comet science tracking, modeling, and predicting long before the main event. What's fascinating is how different these 8 comets are from each other. We have our Interstellar Visitor 3 I Atlas carrying alien chemistry versus the solar system natives that formed right here in our cosmic neighborhood. We have potential naked eye spectacles, like a 6 Lemon and R2 Swan, versus the distant faint whispers of comets like Virchtos and Growler. Some are structurally robust, having survived millions of years in the outer solar system, while others, like K1 Atlas, might be so fragile they won't survive their first close encounter with our Sun. This diversity isn't just scientifically interesting, it's telling us that comet formation and evolution is far more complex than we once thought. Each comet is like a different chapter in the story of our solar system's formation and evolution. Of course, comets have been changing our understanding of the universe for centuries. Halley's Comet taught us about orbital mechanics and helped prove that some celestial objects follow predictable paths. Shoemaker-Levy 9's collision with Jupiter in 1994 showed us the very real danger that comets can pose to planets. More recently, Comet Bernardini-Bernstein, discovered in 2021, broke records as the largest comet ever detected, with a nucleus estimated at over 80 miles across. Larger than most asteroids, each major comet discovery has pushed the boundaries of what we thought possible. But 2025 might be the year that tops them all. Never before have we had an interstellar visitor accompanied by such a parade of solar system comets, all visible simultaneously. It's like having a cosmic museum exhibition, where we can compare specimens from different eras and locations in space. Why does NASA care so much about tracking these visitors? The answer goes beyond scientific curiosity, though that curiosity is immense. Comets are our most accessible samples of the primordial solar system. While planets have been geologically active for billions of years, destroying evidence of their formation, comets have been preserved in the deep freeze of space. By studying their composition, we're reading the original recipe for planetary formation. Some scientists believe comets delivered much of Earth's water and possibly even the organic compounds that led to life. Every comet we study adds another piece to the puzzle of how we got here. But there's also a protective element to comet monitoring. While none of our current visitors pose any threat to Earth, comets can be unpredictable. They can fragment, change trajectories, or develop unexpected activity. NASA's Planetary Defense Coordination Office tracks all near-Earth objects, including comets, as part of our early warning system for potential impact threats. As we look up at the night sky in 2025, we're witnessing something genuinely extraordinary. 8 comets, each carrying its own cosmic story, are visiting our inner solar system simultaneously. From the interstellar messenger 3, I-Atlas, to the potentially spectacular C-2025 R2 Swan, we're seeing the universe deliver a masterclass in celestial mechanics and chemistry. These aren't just pretty objects to photograph. They're messengers from deep time, carrying news from the birth of solar systems and the space between stars. NASA's vigilant tracking ensures we don't just marvel at their beauty, but learn from their secrets and stay prepared for whatever the cosmos might send our way next. The year of the comets is far from over, and the best views may still be ahead of us. Keep looking up, because right now, the universe is putting on a show that won't be repeated in our lifetimes. If you enjoyed this dive into the mysteries of comets and want to stay updated on all the latest space science discoveries, make sure to subscribe and hit that notification bell. The cosmos never stops delivering amazing stories, and we'll be here to explain them all.